Hello and welcome to a new episode of Coffee Source Investigations with me, Francis Beck. This is the series in which we're here at my garden building up forensic laboratory, the MCSI lab, mice crop source investigation. So it is, of course, broader than just coffee, but here on the coffee channel, of course, we will zoom in on the coffee aspect of it. And the whole idea is, of course, to be able to trace where coffee comes from, at least to do a sanity check on where people claim their crops or their coffees are coming from. So this is the whole process where you actually need to liquefy your sample. And the first step to do that is grinding the coffee, for which I have this Teflon grinding jar set with grinding balls, all in Teflon. And the reason is that you need something inert. If you would be using a metal grind set with a metal ball, some atoms of your metal could come into your sample. So instead, you see, these are kind of Teflon jars. You can put some coffee in, and you put a little ball in as well, and then you see, the ball actually takes up quite a lot of space, I would say. How much coffee could we still get in here? That's actually a question, one that we can answer directly. But you see, this is then how you would try to grind it. We have 2 jars for that purpose, and now let's just give a quick check on how much coffee we actually get in here next to the bowl. And of course, you would expect you need to leave some space for the bowl to do its thing. Of course, this is in my office. There's always some coffee to be found. Now specifically, I'm not worried about roasted coffee. That's probably not going to be any problem. It's the raw, green, dry, very hard coffee that is actually. So we're already able to get, 6 grams. Just getting a feeling of how much you get into one surface, but still leaving some room. But I'm hopeful. Maybe 5 grams. So it would mean we're able to grind. So this is now having a total of even 9 grams in here. But of course, this doesn't really leave a lot of wriggling. But who knows? We'll put this up for the test. So let's see how this rolls. So I have been working with the ball mill here to get this coffee ground, and I can tell you it's really not an easy job. Still, I've been trying all sorts of sticks, actually trying to freeze it in between shifts. This has taken around half an hour of continuous vibration at 30 hertz in this tissueizer, and it's still pieces that are bigger than 2-3 millimeters. Quite a big variance in size also, actually. Now the positive thing is, at least for our workflows, this is enough to run this on the ICP-OES, the optical emission spectroscopy. We first, after this grinding step, we need to dissolve it in acid. So this even works on full whole beans, and will definitely work on these smaller pieces. Now the thing is, this step is important because we can only dissolve up to 1 gram of coffee in the acid, meaning you can just use a few of those beans, which then don't really give you a representative set for the plot of coffee that you want to analyze. Because if you're only analyzing 1 coffee bean, for example, that would, of course, correspond with 1 exact location of where 1 plant was growing. But we kind of want to know the average for a certain area. So with the setup, we can grind in one vessel like this 5 grams of coffee, maybe even 7 grams, and so get a little bit a representation by 7 grams of coffee for a certain plot. If we're using both jars, of course, we can definitely do, as I did now, 5 grams in each, so that gives us 10 grams of coffee, just enough also to make you one nice cup of brewed coffee. I'm not going to do that. This is actually Teflon, so not really wanting to have any extra PFAS if it's not necessary in my system. So we're going ahead with this one small step at a time. Actually, every step we're taking, we need to be careful that we're not introducing metals in our sample. That's why we want to work with the Teflon. It's an inert material without metals, so not influencing our analysis. So the first step, grinding, we got somewhere. So getting to representational samples, we need to work further on this protocol. There are other options, for example submersing this in liquid nitrogen to really get even a bigger temperature shock, making those very hard raw green beans more brittle, so that the ball here can do its work slightly easier. So I'll continue working on this protocol, and in the next video we'll be looking in how to dissolve these coffee beans in acid. So thank you for following our work here and setting up a forensic workflows for tracing the origins of coffee. I hope you can grasp what it means to do this kind of analysis, how we try to do it, how we have to set up different protocols for the different steps. So in each upcoming episode we'll look at different aspects of this process. Thanks for following, and hope to see you on the next episode.